Right, so today we're going to talk about JSR 3.10, which is a new API for Java 8 for date and time, and the 3.10 project. You know, this is the specification, and this is the reference implementation project. So as you see, this is a cool name for this specification. So I will just call it 3.10 during the presentation, and I just mean it all together. Right, a few words about me. I'm a Java programmer for 7 years. I've been working on different Java projects for 2 years. I'm working in the Rule Financial company in Łódź office. This year also we created a focus group. So currently I was selected a leader for the Java group. We have also .NET group. And the one word about my company. Rule Financial is a provider of the software and advisory for investment in banks and generally the financial institutions all over the world. Mostly our clients are in New York and London because those are the centers of investment banking. And you know, one word explanation, because you may wonder what's the investment banking. Here in Poland is something which is not known, because banks which you know in Poland are the retail banking. So you go to this bank, you put some money there, or you take the loan, and that's it. That's it. And investment banking is a completely different thing. It's all about stock exchanges, commodity markets, bonds, shares, stocks, derivatives products, all that stuff. And as you know, for a couple of years we have this crisis, and many people claim that this financial crisis was caused by excessive use of some of financial products like derivatives. So I always wondered what it means. What are those derivatives products? How does those financial markets work? So this was one of the reasons I started to work for Rule Financial. And if you are also interested in this, so this is good news. We are still hiring. We are growing very fast. 2 years ago, we had 50 people in Łódź office. Now we are close to 200, and we need another 200 developers. So if you are interested and you wanted to know something more about financial markets, let me know. You can contact me. You can find me around here. And if you have any questions, either for Rule Financial, but also for this presentation, for 3.10, just find me somewhere here, or you can contact me via email. Either it's private or the official one. Okay, enough for this. Yeah. So agenda for this presentation. One thing. Yesterday I was sitting on this room, and I noticed that the screen is a bit too low, so I wasn't able to see the bottom part of this. So yesterday evening I tried to modify it a bit and push this text up, so that you can see it better. Unfortunately, the presentation was done originally in Microsoft Office, and I don't have Microsoft Office on this machine. So you will see that in some places the formatting got a bit distorted. Sorry for this. Right. So initially, I will just give you a quick introduction to the ISO standard, because this is needed all during on the other slides. Then we are going to take a look at the current support for date and time in JDK. What are the problems? Why do we need another standard? We're going to take a quick look at general problems with date and time. Why it's difficult? Why it wasn't done properly at the beginning? And then the core, which is 3.10, what's inside, what is the 3.10 API, some examples of applications, and I hope we'll have enough time to cover some additional things, like what's the current status, what's the difference between this 3.10 and Joda. How many of you has used Joda Time? Okay, quite a lot. So some things will sound familiar for you. Right, so I think we can make the problems a bit shorter, because if you use Joda Time, it means that you already noticed that the problems with JDK. So I will not need to cover that that deep. Okay, and if you have any time left, we can have some questions and answers at the end. Okay, quick introduction to ISO. This ISO 8601 is a standard for date and time formatting. When you exchange the data between the date and time data between systems. So here you see the couple of examples how to format the data. Right. So first is the year, four digits of year dash month dash day, just for the pure date. Dashes are optional, but it makes it easier to understand. So I will use them. Notice the order, right? The year is always first because using this order you automatically get the natural sorting, right? So if you sort the dates using string sorting, you will get the dates sorted in the natural order. So this is nice, and I think this was the reason for choosing this format. Here you see the more advanced one. There is a date plus some time component. Notice that the time is separated from date using capital T, probably T for time. And why they choose this T instead of space, I don't know. But I think we all know that spaces in computing used to cause problems. So this is probably why they came up with T instead of space. And so we have hours, minutes, seconds, then milliseconds separated by dot, and the offset, right? Offset from UTC. This is the current offset we have here in Poland in the summertime. Right? In Poland, in summertime, it's plus 2 hours against UTC. In winter time, it's +1. Short annotation: the seconds and milliseconds are defaulted to 0. And because UTC is so popular and interchange data between date and time between systems, they created the shorthand symbol for UTC. So instead of writing plus or minus 0000, you just write Z, Zulu time. Z is the same as UTC or GMT. It's all the same. And another example, just time without date, and offset. In this case, it's -4 hours and a half. And if you wonder, is it possible? Yes, there are some countries in the world where the time offset is not a full hour, but it's half. And one important thing you need to, it will be needed in other slides. So if you want to recalculate from one time zone to another. So for example, in UTC it's 12. So what time is here in Poland? Because we are in +2 time zone, you need to add 2 to this time. So it's 2 p.m. And if you take a look at this, it's a bit counterintuitive, right? Because if you treat it as an equation, it doesn't hold, right? 14 plus 2, you would expect 16 on the side. It doesn't work this way. It's opposite. So it's just the suffix which says what's the difference from this to this. And the same in another direction. 12 minus 430 is 730. Okay, any questions for this? And last, just to mention it, remember, I've seen such problems in the past. Remember, if you exchange the data between systems, for example, you write a web service, right? So never ever try using, almost never try using local way of formatting the data. Always use this ISO formatting for web services. On the other hand, the same date, if you want to display it on GUI, always try, it's normally what users expect, try using the local representation, so that the representation will be different in Poland and then Germany, then UK, right? So this distinguishes. You need to remember about this difference. Okay. What do we have currently in JDK? I think all of you probably have used java.util.Date, and most of you probably use java.util.Calendar. I think you've come across also Java SQL date timestamp. Maybe you've seen this XML data types. And for formatting, we have date format, quite awkward class. And because, as you know, all those were limited and problematic, people came up with the Joda Time. I mean, different libraries, but Joda Time is the most popular and advanced. And as a matter of fact, Joda Time is the base for ThreeTen. So ThreeTen is really the better, improved Joda Time. So as I said, most of you has used already Joda Time, so probably you know the limitations, problems. Just quickly, couple of things. What are the problems with current set? Date time, they are mutable. If you read effective Java, you know that you should prefer immutability. Common problem, the counting of months is from 0 to 11. So I think you've seen many such questions over. If you Google it, you will find easily why November is 10 in calendar. Right? It doesn't make sense. And if you take this part, Java SQL, it's even worse. For example, in the Java SQL date, you have methods which has no parameters, no arguments, but if you call it, it will throw illegal argument exception. So hey, how it's possible? Method has no argument, right? And it throws illegal argument exception. And my favorite one, documentation for the timestamp. So timestamp extends, Java SQL timestamp extends java.util.Date. But if you read the Java doc, it will claim that due to some difference, it's recommended not to view the timestamp values as an instance of java.util.Date. But it is the java.util, it's the instance, right? And the inheritance relationship between those class really denotes implementation inheritance and not the type inheritance. So what they are saying here is just, it means that we were lazy, so we implemented it this way by extending, but you should pretend there is no extension and they are separated. So if you see such things in JDK, so what do you think? What was wrong, the problem is one part, but what is missing is, I think, even the bigger problem with the JDK. So what do you do if you want to express the pure date without type component? For example, the date of birth, right? If you put the date of birth in your system, normally you are not interested in the time or the offset, just the pure date. And the same thing if you have a job which is triggered every day at a given time, you are only interested in modeling the time component, not the date. And you cannot do it with current JDK, obviously. Another example is the difference between time and the time with the offset in a given time zone. Again, you cannot express it in the JDK, this difference. Imagine that you have a system which keeps a payments list, right? Payment list for the October 2012. You cannot express this thing in JDK, October 2012. Durations like this, again, no, you cannot model it, you cannot express it in JDK. One big problem commonly found in many applications, if the application needs to take the current time, usually the program will call system current time millis. But then it starts wondering, how do you test it? In your test, you want to put the application into given state, right? But you cannot control the system time, so it's problematic. For a long time, there was a known pattern called virtual clock. So you have you inject the clock in your system, and you take the current time from the clock, and you have basically two implementations. One is the clock, which is production, which is linked to the system time, and you have second implementation, which is mutable clock. You inject in for your test, and you can put this clock into desired state, so you can change the time of this clock to the given date and time, so you can easily test it, right? But there is no support for this from JDK, so you need to invent it from scratch in every project. And a couple of examples of general problems. I think you know it. For example, what will happen if you add 1 year to this date? There was no 29th of February in 2005. So what's the result? Is it 1st March, or is it 28th of February, or is it exception? Right. The same with adding a month. There is no 31st of April. Right. Another problem. See those two times, right? 1:30 with the time offset 2 and 2:30 with the offset 3. You remember those calculations. So this is the the same time, really. If you put it on some global world timeline and you try to find out the point which it points to, this is the same point. So this is the same date time, but seen from different perspectives, from different time zones. So if you call this, should it return true or false? Is it the same or not? There is no simple answer for this. And the favorite one is a time change. It always causes problems with computers and with people because we will have it in 2 days from now on Sunday at 3 a.m. in the Sunday night on Sunday. We will move our clocks 1 hour back, right? So at 3 a.m. it will go back to 2, and again after 1 hour we'll have the 3 a.m. So we'll have 3 a.m. twice. In spring it's opposite. Time shifts from 2 to 3 a.m. So there are some times in the spring which didn't happen. There was no like 2:30 in the spring. So it's problematic how to handle it, how computers should behave, how people should treat such dates. And as a final examples, the problems, imagine those are things which you maybe even didn't think about. So you see those two constructs which seems more or less the same. You can construct Gregor calendar, or you can call this factor method and get the calendar. Probably it will be Gregor calendar anyway. But if you like to program against interfaces, as I think you should, you may be tempted to use this one. But if you test it, it will work. The problem is that at least I found such information somewhere on the internet that it will work in most of the countries, but not in Thailand. They claim that in Thailand they have a different calendar. So imagine you have your software and suddenly you sell it to the customer in Thailand, and it suddenly blows up because in Thailand there you will have a different calendar. So would you consider testing your application in Thailand? Probably not. And it's not the problem only for Java. People from other languages have the same problem. For example, if you were the lucky iPhone user 2 years ago, you could be out of luck on one unlucky day in October because after the time change, the alarm clock on iPhone went off 1 hour later. So the programmer who wrote this application didn't really understand how to handle time. And I was told that similar problem exists in XSLT. There is some bug in XSLT that for converting the dates, XSLT takes the current offset, not the offset related to the given date, right? So for example, now we are in the summertime, but if you take the date from December, then the offset in December here in Poland is +1, and now it's +2. So if you convert the December date, you should take the +1 offset because this is the winter one. And I was told that XSLT uses the current, right? So for December date, it will use the winter summer offset if it is cold in summer. So you write the application, it works, but after half a year, suddenly it stops working because in your country the time has changed. What could you do? What are workarounds? If you, for example, want to model the date of birth, you can obviously use string. This is the simplest solution. You can use string for everything, as you know, but usually it's not the best approach. Popular approach is, I'm asking this question on most of interviews in my company, and people come up with different solutions. Usually they claim that you just take the date and normalize some of components. So for this date, you would set hours, minutes to null, nullify all the time components. It's misleading because now if you, for example, try to store such timestamp in the database, this date in the database, it's possible the database will be in the different time zone. So here we have in +2, and your database is running, for example, in London. So there is one hour shift between time zones. So the database will convert this time to the 1 hour earlier, right? So you will be surprised that you in the database you will see 28th of February and 11 p.m. right? Obviously, when you retrieve it back, it shifts it back, so the result will be the same. But if you retrieved it in a different time zone, the reason will be different. So you can by mistake just move the day by one. Also, it's possible that in some time zones that time change happens not at 2 or 3 a.m. but around midnight. So it's possible that under some special cases there is really no midnight, right? If you try to construct such date, it will blow out. So imagine such situation that you have your application running on the production, and after months or even years, suddenly it crashes because you created the midnight date, which is invalid in that special date in time. Right, so this is really tricky. You can obviously write your own class, but it will still be probably tricky. And probably the best answer currently is to use Joda Time, because Joda Time solves such problems. And once Java 8 is released, you can switch to ThreeTen, and this will be the best solution then. And obviously, I'm not able to cover this topic, but the problem obviously is integration with mappers like JPA, how will Hibernate handle such days, how it will be mapped to onto the database type. So it's a topic for another presentation. Right, so we've seen problems. Obviously there are workarounds, but time has come when people decided that there is need to finally fix it. And because Joda Time was already popular, the author of Joda Time is a leader of this ThreeTen specification. And in Java 8 we will have a new API for date and time. So what's inside? First information. This API is, if you take a look at this, it looks like really modern API. So things like immutable classes. Most of classes in ThreeTen are immutable. Most of those classes do not have constructors. For construct the classes, you need to use the factory methods. The API is really clear, consistent, and in most cases you don't even need to read the Java docs. The names of the methods are really nice and self-describing. So yeah, really nice modern API. However, a little bit bigger, definitely bigger than java.util.Date and java.util.Calendar. You will see it soon. I think the most important thing you need to understand about ThreeTen is the two concepts of time. There is machine time model and human time model. What's the difference? You think how computers understand time. So computers don't know what's month, year, hour, minute, and so on. What's inside computer is just the counter, which ticks every millisecond or nanosecond and increases, right? And there is some reference point in the time when it started ticking, which is a 0 time. So for the computer, the time is just the integer number or long number. This unique, famous Unix time, which is just a number. So it's the number of ticks of the internal clock, and that's it. That's basically it for the computer understanding of the time. And people treat time completely different. If I ask you what's the time now, you would say that it's year 2012, month, October, and so on, so on. So for the people, time is a set of fields, name of the field and the value. So one of the best thing about ThreeTen is that author of this specification observed and decided that those two models are so different; they are completely separated. So you cannot. The model is complex, right? So you cannot express it in a simplistic way. So there is no possibility to model it properly using one class like java.util.Date, because those are two different, completely different models. So let's first take a look at the machine time model. There are basically two classes. First is the instant, and the second is duration. What's the instant? Instant is just the, if you imagine the time as the line, right? The axis. There is some reference point, which is in this case it's 1st January to 1970, well-known date, and this scale has nanosecond precision, and you can find a point on this line. So for every time you can imagine, you can show exactly one point on this scale. So this is basically the instant. Instant is the point on the world timeline, right? Duration is if you take 2 points and subtract one from another, the result is duration. So it's a difference between two instances. It can be positive or negative depending on the direction, which element you subtract from which. And that's it. What can you do with this? Not really much. What can people do with such things? Not much, because it's not a human way of thinking about time. So you can compare two instances, find out which is before which. You can use it in some logs, timestamps, things like this. Not that much, but it's important, as you will see. And now, the interesting part is the human model of the time. And here you will see there's lots of classes. So first we have local date. For example, date of birth, right? Just year, month, and day, nothing more. No time, no offset, no time zone. And similar local time, just time, no date, no offset. If you combine those two, so local date plus local time, you will get local date time. This one, date, t, time. Can you transform those objects into instant, into machine time? Can you? You cannot, because there is some information missing. If you have this date and time, this date and time happened at a different time in different countries, because the different countries uses different offsets. So in Poland, this time was before the same time happened in London and before it happened in New York, right? So you cannot precisely map those elements onto the instant. So there is no direct mapping between local date time and the instant from the machine time. Right, now we have the zone offset class, which models, as the name suggests, the offset from UTC. It can be positive or negative, like plus 5 hours, plus 1, minus 2. Z is UTC, GMT is UTC, the same. CEST, which stands for Central European Summer Time, so this is the time we are currently in until Sunday. So this is the same as plus 2. So zone offset just the model for the offset. Now if you take local date and combine it with zone offset, so local date plus zone offset, the result is offset date. So you see date, no time, but there is an offset. By analogy, if you take local time and you add the zone offset, the result is offset time class. So time plus offset, but no date. So again, can you map those classes onto instant, onto machine time? Again, you cannot, right? Because there is some information missing. Here there is no time, here there is no date. And if you combine those two with the same offset, you will get offset date time. So date, time, and the offset. And this is the first class which there is the direct link between this class and instant. So you can easily map this instant, this date time onto the machine time, which is this instant class, right? Because you know what's the date, what's the time, and you know in what offset. So you can precisely map and find the instant for it. Right. So if you think it's all, you are wrong, because there is more. Another thing, zone ID. For example, this one zone. We are in Poland now, so our zone ID is Europe Warsaw. This is the identifier of this zone ID. So you may wonder, why do we need zone ID if we had this offset? What's the difference between offset and zone ID? Is it this one-to-one? So no, it's not. Why? I think it's quite obvious in one direction, because for given offset like +2, there are different countries which have different zone identifiers. So currently +2 offset is in Poland, which is Europe Warsaw, but it's also in Germany and other countries, and also in Africa countries there is +2 currently, I think, but this zone ID will be different. So you may wonder, maybe in the opposite direction, if we have this, do we need offset? Because for given time zone, we know what's offset there. Obviously, the first problem is that for this time zone there are actually two offsets, right? As I mentioned, in the winter we have +1, in the summertime we have +2. But you may think, but we know what's the date. For example, for the 1st December in this time zone, we will know that this is winter time, so we know the offset is 1. Yes, in most cases you know, but there are some special cases when you don't know. For example, on the Sunday, in 2 days, we will have a case when, as I mentioned, the time will go to the 3 a.m. and suddenly goes back 1 hour. So the time, for example, 2:15 will happen twice. So if you have a date like it will be 28th of October 2012, 2:15, and in this time zone you don't know what's the instant. You cannot map it because there will be twice the same date and at the same time, 2 a.m. Let's say 2:15, right? 2:15 a.m. in this time zone, but first 2:15 will be in the summer time, so it will have the offset +2, and after 1 hour we'll have another 2 a.m., but this time with the offset +1. So to make sure that in any case you are able to map the human time onto the machine time, which is this instant class, you need to really provide both the offset and the time zone, and only then you are absolutely sure you will be able to map those elements. So if you combine offset date time with zone ID, you will have zoned date time, which is the full one. So date, time, offset, and zone ID. And as you notice, there is no zoned time or zoned date. There is only zoned date time. Last thing here is the period, which is a simple class for modeling time unit with multiplier, like 1 hour, 5 hours, 5 years, and so on. So for example, you can have this zone date time, and you want to increase it by 5 hours, so you can add period 5 hours to this zone date time, and as a result, you will get a copy of zone date time 5 hours later. Yeah?
It's winter time, the third row.
Mm-hmm.
Winter time, and it's +2.
Yeah, right. Sorry, my mistake. Should be 1. It's December. Yeah, that's true. Should be 1. Good point. Okay, so if you thought you were wrong. There is lots of more things in ThreeTen. So first we have a clock, which is what I described, this abstract clock pattern. So it implements this pattern. So you can inject this clock into your classes, and by default you will get different implementations of clock. So you can have a clock which is bound to the system clock. You will have another which is bound to system clock, but in the UTC time zone, because it can be useful. You can have a clock which is fixed. So for testing, you can use it to fix the time for any date you wish, and this clock will not tick. You can have clocks which tick, which have a precision, not milliseconds, but for example 1 second. So you will have a clock which ticks every second. This can again be useful for testing, because you don't have to bother with this milliseconds components. ISO chronology, which is for representation of the Gregorian calendar. You can have also other calendars, Coptic, maybe Thailand. But this one is the default one. You have also some other helper models, like the pure year and month, month and day without year, quarter of year, and things like this. You have the model replacement for date format, which is called date time formatter, and really quite a bigger set of other helper classes, more like low level. So you like to extend it, build something more complex, you can use those classes. But really, what in most cases what you will be interested in is the clock plus this human classes. This is the basic set. All right, so it's about the theory, and now let's take a look at some examples. How much time do we have? Okay. All right, so you want to construct the local date. As I said, there are no constructors here, just the factory method. So for most of these cases, you will have the off factory method. You pass the fields, and you have the 1st March 2012 local date. Similar is the parse method. So you pass the ISO string representation, and it will be parsed to the local date. Very similar thing with time. You pass the hour and minutes, or you parse the string. And just notice this 00, what really means is the octal notation for the time. So it looks good in this case, but if you try to express like 11.8, so 08 will not compile, because there is no 8 digit in octal notation. So kind of trick here. Now remember, I mentioned at the beginning, you can't express the difference between time without time zone and time with time zone in the JDK. So with ThreeTen you can do it. Local time, we've already seen it. Now if you combine local time with the zone offset, so for example zone offset +2, you will have offset time. So this is a time plus offset. Alternatively, there is another factory method for zone offset. It's a bit strange why it's not parse here. By analogy to previous examples, I think it's because this is really the identifier. It's not something you need to parse, split into different parts. It's just treated as an identifier. This is why it's off, not parse method. Right, so this is simple offset time. Right, so the difference between this and this is that here we have additional information about the offset. Another example, remember I mentioned the payment list. You would like to link to the month and the year, but without date, because you are not interested in the date where it was really paid. You are only interested in the month and year. So you can construct it with ThreeTen. Just year, and there is an enum for months. Here it's a bit more problematic. You would like to express that this time, the marathon record, the world record is like this, and now how to model it. So the problem is that for human model, you remember there is only a period class, but the period it's only for 1 unit of time. So you could construct the period of 2 hours, you could construct the period of 3 minutes, but there is no such thing like 2 hours, 3 minutes. So you would need to move it to the common denominator, so express it, for example, as seconds or milliseconds. So there is no simple way to do it. Here is an example of the code you could use. So we would use, instead of periods, we would use the duration, which is from the human, from the machine time model, not from the human, right? So you construct the duration of 2 hours, then you modify it by adding 3 minutes. There is no plus minute, unfortunately, method, so you need to do it this way. It will return the copy of the duration increased by this time, and again, you add seconds, it will return another copy of this duration which represent this. And if you wonder what's inside this duration, how it's modeled, is it that there is a 2 hours and 3 minutes? Obviously it's not, because the duration is from the machine time data set, right? So for machine, there is no such thing like date, hours, and so on. For machine, it's just the number of milliseconds. So it will be all converted into the number of milliseconds instead. So really, it will be not like this. It will be just number of probably nanoseconds really inside. I'm not sure if it's inconsistent. You know, if you really think about this, what's this? So at least in this case, what is the marathon record time? It's what happened. The marathon started at some instant of the time, ended at some instant, and what you calculate the difference between those two instances. So it's not directly tied to any date, time, and so on. It's just the difference between two instances. So it makes sense to treat it as a machine time, as just a number of milliseconds, because if you try to model it this way, keep it internally as 2 hours and 3 minutes and 38 seconds, what would be the added value? What would be the advantage against keeping it as a number of milliseconds? Sorry. This is a factory method, right? So this is a kind of constructor. So this is different, and it could be a method like plus minutes. For some reason, I think they just there is always problem of the size. I hope I will just touch this problem in the end. How many methods you add, the more is sometimes better, sometimes worse. So probably they decided that in most cases you will just add the seconds, and for other cases you can use this. So if you want to add hours, you can use plus local period unit hours. And for your convenience, they decided that probably in most cases it will be just seconds. So there is additional this method, but you could use it here like plus 38, comma local period unit seconds, right? So it would be more consistent then. Mm-hmm. It's close to the final, so it's not yet fully stable. This is why it's not really recommended to use it in production. It's getting to the final state currently. So if you have any comments, improvements, you can obviously send email to the mailing list, propose it. Yeah.
Are there any period units other than local? I mean, are there other minutes that are
I don't know. I've never seen it. A good question. I don't know. I'm not sure if there is something different, but yeah, the name suggests that should be something. So we can check after the presentation. And the usage of clock, right? So instead of using this, there is a method which you will return it will get you the local date time with the current underlying system time, but it's not recommended. What you really should do is inject the clock and pass this clock to this method. And this way, in your test, you can easily inject any fake clock, set it to the given time, and this local date time will then represent the time, the one that you set, not the current one. So it's easier to test. Not sure if you see this part here, but here I've just put some examples of different clocks which you can create. So system default zone, the basic one, and the same as is in your system, the same time zone, the same time. System UTC, so it's the same time but converted to the UTC time zone. So for very often especially on the server side, we don't want to be tied to the changing offset, so we prefer to use UTC very often, so you can use this one. You can specify any zone ID which is preferred than this one, because if you use this one, you are really putting some hidden logic inside, which you will depend on the defaults of the system. So it's better to you do it explicitly like this. And you can have the fixed UTC clock. It will require, it will need the instant to be passed here, but because creating the instant manual for people is not easy, so it's better to create the offset datetime like this, and then call to instant. It will convert this offset datetime to the instant, which is the machine time, and you will get the clock which is fixed to this instant, and it will not move. Yeah, so here you see this artifacts of this formatting. Sorry. Another example is what will happen if you add 1 year to this date. I remember I mentioned this. It's not easy. What will happen, especially currently in the clock in the calendar class? It depends. You can switch calendar to different modes, and it will depend differently. So in ThreeTen, it's always easy. It will always move back to the latest valid date. So you will just get the last February of this year, and in this year, last February was the 28th. The same thing with months. If you add 1 month to the 31 of March, you will get the 30 of April. By the way, here you see the example of month day, right? So first I create the month day, so there is no information about the year. Unfortunately, this class doesn't have the plus months methods, so it's not able to calculate this. So first you need to convert it to the full local date by calling this add year, and then you can add the month, and you will get the 30th of April. Mm-hmm. From this, for example, you will get 28th of February. Yeah, I mean, I've seen already such question, because some people told me that calendar is a good class because in calendar you have this trick that calendar can keep internally the invalid state. So if you, for example, on the GUI you have the drop downs and you can click up and down the date, it will keep internal initial state, and it will know that if you go from this to that and then you will go back, you will end up with the original date. So I can't say for sure why it's not in the specification, but my understanding is that, at least how I feel it, that something inherently wrong if you try to model such case using the some GUI, really the GUI case in the date model. So because it's not a normal way of calculating the date. So instead I think what you should really do is have kind of wrapper model for your GUI component, and this wrapper would keep this date internally as a base date, and every calculation you should do against this date. So if your user clicked twice plus, then what you really do is call this initial date plus 2 months or plus 2 years, and if it clicks it backs you again calculate it all against this initial date, and then it will work. So it's a kind of separation of concept, right? So you shouldn't mix the GUI special behavior with the data time modeling, right? So those are different things. From my perspective, it's a GUI thing, because server doesn't think it this way. Maybe in some special cases, then you can have another wrapper of this. I think there was something like this, but I'm not sure at this moment. We need to take. Okay, sorry, because we are getting out of time. So just to show you a couple of more examples. the comparison, what I mentioned before, is it true? So if you compare those two, they'll create two offset times, and you compare those two, it will return false, because for it will compare the fields, so the hour is different, offset is different. But if you try to convert those 2 days into instance and compare them, then it will return true. So there is also, instead of converting those two to instance, there is also the utility method equal instance, and it will return true, right? And the last funny example here is that for this time change we'll have in 2 days. Imagine you created the zone date time. This is kind of special case, so this is a bit complex. But what we do here is to create this date with offset +2 and in the zone ID Europe Warsaw. So if we call plus hours, what will be the result? The result will be free. Initially it was 2:15, and after adding 1 hour, it will be 3:15. So it makes sense. But if you think about this, what's really inside, if you try to convert those two classes to instance and subtract them, so to calculate the duration, you will really get duration of 2 hours. Because what happened really is that from 2:15 the clock went to 3 a.m. and then it moved back to 2 and again moved to 3 and then it moved to 3:15. So 2 hours passed, right? So it's really good documented in this method. So if you take a look at this method, this behavior is documented. It understands that in the human thinking, this behavior is correct. If you really want to make sure that it's really added the duration of 1 hour, then you need to really convert it first to instant, then add the duration of 1 hour, and then convert it back to zone date time. And then you will see that 2:15 plus 1 hour, it's again 2:15. But the only thing that has changed is that we moved from summertime to winter time, right? So it's getting a bit tricky. Yeah, you can call.
Okay, I'm sorry, but we're running out of time.
But we started a bit later.
2 minutes later.
Okay, so 1 minute, one last minute.
Just 1 more minute.
Yeah, okay, this is interesting thing, but unfortunately I will not cover it here. So what's the status? As I said, it will be ready in Java 8. It's a better. Why it's not Joda? Joda has some problems, some minor problems, so they decided to fix it before making it standard, which is why ThreeTen was created. And so if you want to use it now, prefer using Joda because it's stable, and after 1 year, when it's out, you can use ThreeTen. They currently have some problems with defining of the module size, right? This is what I mentioned. Sometimes for Java EE, more methods is better. For Java ME, more methods is worse. So there are some discussion about this. So as a summary, few things I would like you to remember from this presentation if you didn't know it before. In Java 8, we'll have this new API based on Joda Time. The reference implementation is called ThreeTen. If you've used java.util.Date or calendar until now, stop use Joda Time instead, and in the future ThreeTen. Never ever try to use in your logic this current time millis. Use this clock pattern instead. And if you exchange data between system, one final note, use always this ISO standard, which I covered at the beginning. Okay, thank you for your time. If you have any questions, I will be around somewhere here, so you can find me and I can explain more. Thank you.
Thank you very much for the presentation.